Hi friends, welcome back to our digital VLSI channel. I hope you guys are doing well. In the last video, we discussed about how 2x1 multiplexer works and its Verilog code. A 2x1 multiplexer that selects one of two input signals based on a control signal. Today I am going to discuss about 4x1 multiplexer which selects one of four input signals based on two control signals. By the end of this video, you will have a clear understanding of how a 4x1 multiplexer works and how to write Verilog code to implement it. Now let's get started. The 4x1 multiplexer is also known as a 4 to 1 multiplexer, and it has four inputs and two selection inputs and one single output. Here the output is selected as one of the four inputs which is based on the selection inputs. Since there are n selection lines, so there will be a 2 power n possible combinations of inputs. Here n is equal to 2 selection lines. So 2 square is to 1, that is 4 is to 1. 4 input lines, one output line. And this is the block diagram of 4x1 multiplexer, and it has four input lines and two selection inputs and one output where I0, I1, I2, I3 are the four inputs and S0, S1 are the two selection inputs and Y is the output. Now let's draw the truth table. S0, S1, Y. Here we have two selection inputs, so four possible combinations we will get. The combinations are 0, 0, 0, 1, 1, 0, 1, 1. When S0, S0, S1 is equal to 0, 0, the input I0 is selected. When S0, S1 is equal to 0, 1, I1 is selected. When S0, S1 is equal to 1, 0, I2, the input I2 is selected. When S0, S1 is equal to 1, 1, I3 is selected. And this is the truth table. From this truth table, we can write logical expression as Y is equal to S0 bar S1 bar into I0 plus S0 bar S1 into I1 plus S1 into S0 bar into I2 plus S0 into S1 into I3. And this is the logical expression. Now let's draw the hardware circuit. S0 and its complement S0 bar S1 and its complement S1 bar. And what are the inputs? I0, I1, I2 and I3. What is the first mean term? S0 bar, S1 bar and I0 are connected to one AND gate. And what is the second min term? S1, S1 bar, S0 bar, and then I1, and these three connecting to another AND gate. S0 bar, the third multiplication term, S0 bar, S1 and I2 are connected to another AND gate. And what is the last min term? S0, S1 and I3, and these three connected to another AND gate. And these all three multiplication terms are added together using a OR gate. The output of the OR gate is the final output of the multiplexer. As you can see, the 4x1 mux allow us to select one of four input signals, that is I0, I1, I2, I3, and transmit it through a single medium. This is the main advantage of the 4x1 multiplexer. It enables us to transmit a large number of signals over a single channel. I hope this explanation and the circuit diagram have helped you understand how a 4x1 multiplexer works. Now let's take a look at the Verilog code. First start with module followed by some name mux underscore 4x1. What are the inputs? Input I0, I1, I2, I3. Selection inputs 1 down to 0. Yes. Output. Next, I am going to use always statement. So here output signal is declared as type reg in the module port list because it is used in a procedural block. So reg y, here I am using always statement followed by begin end block. Always statements can be executed every time it's once its sensitivity list gets triggered. In most cases, input variables are present in the sensitivity list. Another way of expressing this list is by using a asterisk symbol. So always at asterisk begin. Next, to describe the behavior of 4x1 mux, I'm using the case statement over here. Case statement start with the case keyword and ends with the end case. So case. So when S0 and S1 is equal to 0, input is transferred to the output. So 2 tick, based on the truth table, I'm writing here 2 tick B00 y is equal to, if S0 and S1 is equal to 0, 0, input I0 is transferred to the output. Similarly, 2 tick B01 y is equal to I1, 2 tick B10 y is equal to I2, 2 tick B11 y is equal to I3, end case, and then end, finally end with end module. With this our design code is done. Now let's move on to the test bench. Module TB Inputs as edges, outputs as wires. I0, comma, I1, comma, I2, comma, I3. Reg 1 down to 0. Yes. Wire. Now we need to instantiate our design module to the test module 4 cross 1 DUT I0, comma, I1, comma, I2, comma, I3, comma, S, comma, Y. Initial, begin, repeat of 4, begin. Here I am using $random. Simulator itself will pick some random values and assign to it. And then I am giving instant time delay for printing those values. $display I0 is equal to percentage %b, comma, I1 is equal to percentage %b, comma, I2 is equal to percentage %b, comma, I3 is equal to percentage %b, comma, S is equal to percentage %b, comma, Y is equal to percentage %b, I0, comma, I1, comma, I2, comma, I3, comma, S, comma, Y, and then end, one more end, and then end module. With this our test bench is done. Now let's run the code. This is the output we got. As you can see, the input selection input 0 0, input I0 is connected to output Y. Here I0 value is 1, so Y is equal to 1. That's it for today's video on the 4 cross 1 multiplexer. I hope you found it informative and helpful. Thank you so much for watching, and don't forget to like, share and subscribe for more videos.